Good evening. So it's like we are in week 5 right now, so halfway through the course. So I got a chance to go through the feedback that you have submitted for the problem solving sessions. There were some queries on the type of questions to expect in the final exam, which I requested one of the TA who will be handling the final exams to actually join our session. He will be answering that question once he joins, maybe like 30 minutes into the session. And there are also some questions on needed some detailed explanation, but the feedback given was quite ambiguous, like it isn't specified what exactly is required. So if one of you who have joined has any other queries or needed any specific explanation or any type of questions that you want me to discuss during the session, you can let me know during the session, or when you specify in the feedback form, please be more specific so that I can address them. Okay, so the last week we discussed on optimization algorithms. So when we were discussing these optimization algorithms, I've shown you one code, and then we have come to a conclusion that depending on your problem, you do not know which optimization algorithm to use beforehand itself. So it changes from problem to problem. So I'm just taking 3 methods now. So we have steepest gradient descent, where your update is directly dependent on your gradient. Momentum method is when you know that as and when your gradient becomes small, your update also becomes small, which is something we don't want to happen. So if this is your landscape, or essentially your errors, how your error function behaves, then if in regions like this where you have very low values of gradient, your optimization steepest gradient descent would not go ahead, so you would need some momentum. So that's why we added another term to that, and that's what we do in the momentum method, so that it will overcome this region. It will eventually move out here, but because of momentum it will actually not stop here, instead it will actually go even further. So we want something to stop that as well. So we came to the conclusion that because of this momentum you will have some oscillations. So in order to reduce that, the next method proposed where instead of actually evaluating it, we actually take a look ahead and then see whether it will actually oscillate or not, and then we actually reduce the step size accordingly depending on this. So this is what we discussed in the last session. So the question that we didn't answer in the last session is, how do you choose optimization algorithm for your problem? So there are 2 other methods also that are discussed, ADA grad and ADA delta, which for now I am just keeping aside. So if suppose you just have three methods, which one of these would you select for this particular scenario that I am choosing here? So the x-axis is your number of iterations or number of epochs as you call it, and y-axis is your cost function or your objective function. So if I told you that I am using momentum method, so what would I do out of these 4 options? What would be my way of how would I go about doing this? So this is how the objective function is behaving with the number of iterations. What should I do? Because the only thing that you can monitor during your training is one, your training loss or your validation loss if you have a validation data. So we'll come to bias variance a little later, but for now just say you have the training data and this is how it behaves. Your optimization function, like your objective function, is actually behaving in this way with the number of epochs. So what would you do? Is it because of the model? Like you would change the model or change the parameters of optimization? This is something that we are leaving for now, like whether to change the model or not. You would be needing both training and validation data, put them side by side, and then you will decide what to do with the model. So for now I am leaving this aside. So we are not considering the possibility that model could be changed, the parameters in the model could be changed. So the only option now I have is I could change the parameters for optimization. So if I am using momentum method, my parameters are alpha and gamma. So what would I do in this case for this particular objective function? Like if this is the scenario that is shown. So my alpha is learning rate, and gamma is my momentum operator. I'll just write momentum here. So in this equation, this is gamma and this is alpha. So weight depends on the previous steps. The weightage given to the previous steps is given by gamma, and alpha is the weightage given to the gradient term. So if this is my objective function, what would you do? Okay, maybe even before asking this question, maybe I'll put the question little differently. So you know there are three methods here, and you know that last week we told that you cannot choose any optimization algorithm beforehand. So we need to try it on your data set and then see if it is working or not. So why do you think that we cannot say beforehand whether a particular algorithm will work for it or not? So what is it that is changing from problem to problem? The algorithm is the same. So what is it that is changing from problem to problem? So is the question clear or convergence? Yeah, so why is the convergence changing from problem to problem? So the algorithm is the same because of learning rate. Okay, say if I keep the learning rate same, then and yeah, it's right in front here. So you have a learning rate is one thing that could change. Step size to next minima. Yeah, step size to next minima is your delta Wn. That will change from problem to problem because of something else, right? It is because of the gradient. It is because of your objective function, which again depends on the weights that you have previously. So if I use the same objective function, will this be same for everything? So say if I am using least squares as like if I am using the mean square error as my loss function, can I fix my optimization routine, or is it like will it also change from problem to problem? So basically the landscape, or what this is what I am calling a landscape, or essentially how your error function behaves in the parameter space of your variables or your parameters. So whatever model you have chosen, it will have some parameters. So within the parameter space you will have a landscape or essentially some function. So my error function here is j, which is a function of w. If I plot the various w's, say if I have a linear regression model, in linear regression what are my parameters? What are the parameters in linear regression? So if my model is y hat equal to ax plus or w0 x plus w1, then my parameters are w0 and w1. If my objective function is, if say I am still using the least squares or mean square error as my objective function, so what I would be requiring here is j as a function of w0 and w1. So if I were to plot this, so if this is my w0, w1, and so like just say it's 3D, w1, or maybe I'll put this as my objective function and this as my w1. So it's like xyz. So my objective function will be a surface. So we just don't know how the surface will be. The shape of the surface will be dependent on the data you have. It depends on these parameters as well as the data you are going to have. Since we do not know either the data or these parameters beforehand, we cannot say which optimization will be better for one. If the scenario is just this particular portion, If you just have something like this, then maybe a simple gradient descent would be working. If it has something like this, then you might have to use momentum method, because here you are also need to store the previous weights. It's going to be a little more computationally more complex than the previous one. So depending on your solution space or your landscape is what I call that, your optimization algorithm will change from problem to problem. Now we have only these three optimization algorithms. Within that, now you mentioned because of learning rate also it will change. So now for this particular scenario, like when you are training a particular model, this is what you have observed. See, now that we don't know which optimization to use beforehand, what we do is fix an optimization algorithm, run it, and kind of diagnose it. Diagnose in the sense we actually monitor what is the training loss or how is the objective function changing with the number of iterations, and then we have seen this thing. Now after seeing this, how would you change your parameters in your optimization? So what would you do now if this is how it is? What we expect usually for the objective function is, as your iterations increase, it should smoothly converge to some minima. This is what is expected, but instead you are having some oscillations here and there. So what would you do if there are oscillations? It's like we discussed last week. So if you have more oscillations, your learning rate should be, so if alpha decreases, then your oscillations will decrease. If your gamma decreases, your oscillations will decrease. So if I want to reduce the number of oscillations, then I have to reduce these four. I can actually set gamma to 0 and see if it actually, okay, say now I have two things. I have both alpha and gamma, and both of them are actually contributing to oscillations. Now what I can do is make one of them to 0. Say I made gamma equal to 0, and then see if it is actually proceeding in the right direction. So after making gamma equal to 0, then I'll again monitor this loss, and if the loss is something like this in this particular portion, then I see the step sizes are very small, then I'll keep on increasing gamma little by little. This is all something that you don't have to do manually. This automatically adaptively changing the value of gamma and alpha is already taken care in something called adaptive momentum method, which also accounts for the fact that as you go near and near, so if you are in this region, previously we told that because of momentum you will not stop here, instead you will move there, then you will keep on oscillating in this particular valley itself, which is something that you don't want. In order to prevent that, what we need to do is actually decay the value of momentum. That is something that is automatically done in Adam operator, Adam optimizer, which is also available in your PyTorch and TensorFlow if you are already familiar with it. So we are not going into that, but just wanted you let me know that there is some optimizer for that. Okay, now let's get started with this week. So this week we introduced the neural networks. So what are the basic components of a neural network apart from your input? So you have an input, and then you have some linear combination of it, so you actually do some transformation on it, and then you apply a nonlinear activation to it, and then you get some output of the neuron. This is one neuron inside your neural network. So this part is clear, I guess there are no queries in this. So now what is the activation function that we will be using? So what are some of the activation functions that you are already aware of? Sigmoid function is something that is already introduced in the week lectures. Right, sigmoid of x is so another activation function that you would be using is tan hx. ReLU. So ReLU you are already aware. Okay. Any other activation functions? So what is ReLU? to those of you who are not familiar with ReLU, so ReLU is rectified linear unit. So what it essentially does is, for say positive value, you can change these values, but I'm just giving the default ones. So if it is negative, it will be 0, and for all the positive values, you will have a value of 1, or sorry, you will have a value of x taken directly. Okay, so let's say we have these 3. So the question now is, can I use any of these activation functions, or this is also something that I have to try and experiment and see things work or not? So why do you think, which of these, say sigmoid and tan h, can I use any one of them, or does it change from problem to problem or something like that? So the first question here is a simple neural network. It's a 2-layer network, but there are no any multiple neurons within the same layer. I'm just taking a single neuron. So if this is the network I am having, and I am using a sigmoid activation function, what the question asks you is, now if I change the sigmoid activation to tan h, so will I be able to still get a network that will be able to map the relation between x and y or not? So essentially what I am doing now is y I am writing as a function of, it's as a neural network with sigmoid activation function of x. Can I write this using a tan h function? So if I were to use a tan h function, so what would be the difference between sigmoid and tan h? Why sigmoid, why tan h? Any comments? Or it just doesn't matter? Whatever is available, we'll just use it, or something like that. Okay, let's first try to answer this question. So if I use sigmoid, I know that the mapping is proper. So how do I write this function here? So what is y? So x first goes through the first network. So it becomes w1x plus b1. Maybe I'll write it in steps. So how does your neural network work? First you pass the weights. From there it becomes w1x plus b1. And then you pass through your activation function sigmoid. So you have sigmoid of w1x plus b1. So this entire thing is your first neuron, and from there you pass the second weights w2 b2, and then similar thing happens here, and finally you have y. So y is now sigmoid of this is straightforward. This is clear, right? Are there any queries in this? So how am I writing this? Is like, you have x, you have the weights, you multiply with it, and then I pass it through the sigmoid function. That is your component here. This is the first neuron. Once you pass through it, and then you again multiply with the second network weights w2 and b2, and then you finally get your y. So now here we have two things. One is your weights and your bias. So why do I have to keep this bias? Maybe we'll come to that a little later. So there was a question even in the forum. So maybe we'll come a little later if the person joins. So this is clear. So are sigma and tan h related to each other? Yeah, I think Nitin is also here now. Hi Nitin. Okay, so how are sigmoid and tan h related here?
Hello.
Yeah.
Hi Durga.
Hi.
So I am available now.
Yeah, so there were questions on essentially the type of questions to expect in the final exam. So if you could give some light on that, then maybe it will be useful.
Hi everyone, my name is Nitin. I'm here to this for this. Please ask Yes. Yeah, I'm aware of. I haven't shared the programming assignment with you. Sorry, I think I might share it after this.
Okay, I think the students who specifically asked the questions are not available in the session. So on behalf of them, I'll just ask you the questions they asked me.
Mhm.
So the first one is the type of questions to expect in the final exam.
So, as I have clarified many times, the all question will be have four options, and one option will be correct, or
No, no.
more than one will be
I
correct.
mean the level of questions to expect, like theoretical or
It will
programming.
be exactly similar to the what asked in assignment. Exactly similar. 80% and 85% will be similar as per assignment. In fact, 50% will be as exactly same question from the assignment. That as per NPTEL rule, if I know, since I have been running this for a long time, many courses I have done. So exact 50% will be similar to the assignment, and more or less similar. We don't give more than that, and
Okay.
there will be no programming question at all. So because in center we cannot, we will only give the question who can be solved using the scientific calculation, because online calculator will be available on the exam portal. So we will only give the questions which can be solved within the time bound using the calculator, which is available on I1 centers. So
Okay. Thanks for that. And then there was also one request asking for some practice papers if they can get any
what practice purpose?
for the final exam.
So
So assignments are
as
sufficient,
per
right?
I guess uh, assignments are sufficient, and I don't think we can share with practice sets. I'll discuss with both professors and let you know if it's allowed or not. Because I guess this course was, in fact, I guess that might not be used,
Hmm.
because the assignment was earlier was quite different what we are giving right now. So
Okay.
it might not very useful, but the suggestion is you can watch video multiple times. So in fact we also learn with the same way. We watch videos multiple times, and you can also look some help material on Google. You simply type some topic on Google, there will be a lot of help material. uh, in fact, a lot of quick materials available. So and then I as per my suggestion, you don't need extra material at all, because I think course is enough to spend a lot of time if you
The specific this
rewatch the videos multiple times.
yeah, the specific query is the maths, the level of math that is required, that they are finding it a little difficult. So that's exactly why they were asking some practice questions. That's exactly the feedback they have given.
Oh, exactly.
So any
Uh,
reference for the math problems to
I
solve is
mean,
what they have
the
asked.
suggestion is, yeah. So I am aware of this kind of, because earlier I think it was little bit easy. Right now we are giving little bit tough, but as per my suggestion is you can take help from other content also. There's a lot of content is available. See, at the end of this the goal of this course is you should learn something as per like our expectation and our little bit expectation. You should know linear algebra, and you know some probability theory, and in fact you have to have some background knowledge. But as per other deep learning concept concern, I think we started from scratch only. I don't think there's any jargon or hi-fi things
No,
are available.
only the
This is a
initial
very
part. Yes.
basic course. So as Durga also knows, very basic course, and there's lot many things exist top of this. So please watch video multiple times. Since I'm handling forum, I can see recurrent, very small recurrent questions comes to us. So my suggestion, you can watch videos multiple times. That might, and please, whenever you're watching the videos, please create the hand notes. That will be more helpful for you. just watching the YouTube video doesn't help you at all, as per my suggestion. Any other doubts?
So these are the major questions. There were some
Yeah.
questions, but they were not specific enough that I can ask you. It's like they are not pointing to any specific one,
You
but
can ask me if I.
yeah, I'll ask you later.
Oh yeah, sure.
Yeah.
Okay, thank you so much. And
Yeah, thanks for joining.
if you have any, there might be a little bit technical errors in PPT. There's one in back propagation video 44 point something. Yeah, we recorded. Professor have recorded this course in way back 2018. So if you feel there's some error, you please ping us in the forum, and we will clarify the doubts if there's any error in the in that PPT or videos. There are multiple errors, and as you know, sometimes it's a man kind error. We cannot minimize them, but we'll clarify on the forum. Okay.
Yeah.
Okay. So I hope you are enjoying the session with Durga, and if you have any technical questions regarding the assignment, regarding the any part of the course, please do ask me. And Sharon, I will share with the programming assignment today. I have the link. Even in fact, I have the video which I recorded for solution purpose and the programming solutions, as well as the question paper also. So I'll share with all three materials with you. So in fact, I'll share the previous version of the question which we used in NPT for the same course assignment questions. So that is also available. So we'll share with night. Please, whoever is available in the forum, please check somewhere Sharon or some other discussion. Okay. Okay. Okay.
Thanks.
Thank
Nitin.
you, Durga.
Yeah,
thank
thank
you.
you.
Or hopefully you're enjoying all the session with Durga. So thank you. Okay.
Thanks.
Thank
Nitin.
you, Durga. Bye.
Bye. Yeah, now I guess the questions are now it is clear with respect to what to expect in the final exam. So now with that done, so let's get back to where we were. So we were trying to relate how sigmoid is related to tan h. So how are these two related? So it's a little bit of math here. So a little bit of geometric manipulation that you have to do. So what do you think you will get here? So I can write tan h as so maybe can I write it as this? So I'll just divided everything with e power minus 6, or maybe I'll divide with e power plus 6, whichever is your way. So I can write this as this becomes so the point here that I want to emphasize is tan h is essentially again a linear combination of your sigmoid functions. Tan h is again a linear combination of your sigmoid functions. So if your weights by actually changing your w1, w2 and b1, you will still be able to get the same value as you got previously. So by actually using tan h or sigmoid, just the values of the weights that you are going to get after optimization are going to change, but you will still be able to model it. But now Sharon also pointed out about this ReLU function. So can I write tan h or sigmoid as a linear combination of ReLU or something? So say if I call it 1, 2 and 3, 2 can be written as a linear combination of 1. So if I use the same network architecture, by using the same network architecture and changing the values of W1 and B1 and changing the weights, I will still be able to get the same result, same mapping between X and Y. But now can I do the same with 1 and 3? Say if I am using sigmoid and ReLU, will I be able to do it? Yes or no? So how do you know is essentially the idea is this. So if you were able to express one activation function as a linear combination of the other one, then you should be able to do it. Otherwise you would not be able to do it. So with that thing, keeping that in mind, can you answer this? So can I write ReLU as a linear combination of sigmoid and tan H or something like that? So sigmoid, I think no. So sigmoid is an exponential function and a ReLU is just a linear function, so you would not be able to write it as that. So why is this particular thing important for us now is, say if you have so now you are already aware of bias and variance trade-off, so maybe one of you can highlight it. So what is bias and variance trade-off? So what is bias? It's basically you have your model which is consistently being different from your results. So this you usually see in terms of training and validation. So if there is a large difference between training and validation, but both of them have kind of flattened out, then you call it a bias. Variance is something else which will come later. So now you have a model that has a bias. So what you wanted to do is you want to change the model. So how do you change your model? Say here we have a neural network. So in neural network, what are the things that I can change? I can change the number of neurons, number of hidden layers, or basically I'll combine both of them and call them architecture. So I can change the architecture. By architecture, what I mean is the way how neurons are connected. These are one category. The second category is I can change the neuron itself. Essentially, I'll change the activation function. So if the previous model that I am using, for which I found out it is a highly biased, and then I have a sigmoid activation function. Now if I change the activation function to tan H, so I would not be getting any advantage from that, right? Because both will actually give me same mapping. The only thing is your weights will have some new values, but eventually both are going to be similar. So if you want to actually change the bias, or if you want to increase the accuracy of your model, then you need to use a different function other than tan H. So choosing your like instead of trying 100 different possibilities, you can actually reduce one of them by understanding the relation between these activation functions. Now coming to the next part, so how do you design your architecture is something that will come a little later, but for now is this clear? So why we are doing this? I think there are no questions in this. Now for the next question, in the lectures there is something that has come up, is called universal approximator. Neural networks are called universal approximators. So what do you mean by that? Is essentially a neural network can be used to map any relation, any functional relation between two variables or between any number of variables. So it will be able to understand the relation. So if I have a y equal to f of x is something that I have originally. So what we will be writing now is instead of f, I am writing it as x comma theta, or I'll just put tilde here, where theta are the parameters of my neural network or weights of my neural network. So this will be approximately equal to this. So what does the neural network do is it tries to approximate the original function f, and then in order to do that it will have some parameters theta that will essentially do that. So what this universal approximation theorem tells us is by actually varying these weights, you will be able to approximate any function to any level of accuracy you want. So this is a property that we will be using in most of the applications. So the one application that one of you brought out in one of the earlier session is PINs. PIN is essentially physics informed neural network. So the idea here is when you have a differential equation, say I have a simple wave equation, so del square u del t square, say I have something like this. So if I want to solve this equation, what we do traditionally is we assume some functional form for u. So u is some a sin kx omega t or something, so we assume some functional form of x comma t, and then we try to substitute in the equation and see if it actually solves this subject to the given boundary and initial conditions. So what we do here with using when you use a neural network is, now we know that neural network is a universal approximator. So we'll approximate this with a neural network that has x variables as xt as my inputs and parameters as theta, and then use this f prime to solve this original equation. So the same property will be used again. Even in your regression is something is the same thing. So regression is about finding say if you have linear regression, what are we doing in linear regression is we are assuming we are coming up with a y hat that is ax plus b. So a and b are your parameters, is what we are identifying through your optimization. So similarly, neural network will have some weights that will try to find by some optimization, and eventually it will have the weights and it will approximate the function f. In linear regression we have fixed the functional form as ax plus b, but in neural network we don't know what the actual functional form is going to be. It will change depending on your weights and architecture. So here is a very simple problem where I am giving you the function y equal to x square, and I wanted you to try to fit a neural network that will actually approximate this function y equal to x square. So how do we go do that? So my original function is y equal to x square. So what I am saying is, now you have to come up with a model, something like this. I know I am using a sigmoid activation function, sigmoid of ax plus b. So I want you to come up with the values of a and b that will actually model this function y equal to x square. So how will I do that? If you are already familiar with programming, like you can use Python or MATLAB, and then how you formulate the problem is you actually start with generating some values of x, say between 0 to 1 is my domain. So you generate some values between 0 to 1, and then for those values, say I am calling it xi, and then you eventually get xyi as xi square. You just square all of them, you have xi, and then you develop a model, you develop a neural network for these xi and yi. If you are using like TensorFlow or something, then you would use some library for it. So once you have the network, then you train it. What will be your objective function? So I'm just calling it this yi hat as nn of nn is my neural network. What I'll give my xi as input, and then some theta. Theta are the parameters of the neural network. In this particular case, theta is a and b. So what will be my objective function here? So is this a regression problem or a classification problem? So here I am trying to identify the relation, like I am trying to get a value for each and value x, like as your x changes, I want to get a continuous change in y. So this is a regression problem. So we discussed in the last session as well, for regression problems, least square, mean square error is your objective function or your cost function. So in this case, it's going to be sigma yi minus yi hat square for whatever number of x you have chosen before, and then you try to minimize this. And then you try to minimize this. So minimization is straightforward. One, if you want to do it analytical, there is a question even in the form between the difference between what different types of optimization algorithms do. So if you are following an analytical method, I'm just showing you how you would go about is something that we already know. So you just do del j del a equal to 0, del j del b equal to 0. So you have two equations. and two unknowns. Your unknowns are A and B. You solve these equations and then you eventually find out A and B. This is what we do in analytical way, which we are not taking. Like, it is quite simple for this particular problem because you just have two parameters, but in real world scenario you will have a number of parameters, so analytical is something that we won't be doing. So what we would be instead doing is we will use numerical algorithm like the one we discussed, the gradient descent or the momentum method or any method of your choice. So from this you calculate the gradient. So how do you calculate gradient? Okay, backprop is already introduced, so you will use backprop and somehow get the gradient, and then from there you eventually use some optimization algorithm and come up with the values of A and B. So this is straightforward. So I do not expect you to solve this now, but if you solve it, you will get a value of A approximately 6 point something and B close to minus 4 point something. But the point I want you to understand now is if I were to plot sigmoid function, so how will sigmoid function look? Maybe I'll just draw here. So for all x negative, your sigmoid will be close to 0, and for positive values it's going to be 1. So you'll have an inflection point at 0. So what are we doing in neural network? So sigmoid of, this is sigmoid of x. So what we are trying to do is vary the sigmoid function somehow and get the function y equal to x square in the limit x equal to 0 to 1. So y equal to x square, I'll use a different color, will be something like this, say 0 to. So my original sigmoid function is this, and I want to somehow convert it into this function, and in order to do that, what we are trying to do is we are putting two constants A and B. So what are these A and B doing here? So when will this function be equal to 0.5? Sigmoid of Ax plus B is 1 by . So this is going to be 0.5 and your x is minus b by a. And a, what will a do? So by actually increasing or decreasing the value of a, what is actually happening is you are actually changing the slope of this line. The slope of this particular line will actually change if you actually increase or decrease the value of a. So if I increase the value of a, so what will happen is, if this is my original function, if I increase the value of a, then it will become something like this. So by actually changing the value of a, I will be trying to change the shape of the sigmoid function. So by actually using number of sigmoid functions, what I will eventually do is I will change these curves and so and then add them up and eventually try to come up to this particular value of function. This is something like, if you are already familiar with Fourier series, that is what we do. We have several sine and cos, and then we try to somehow vary the coefficients between them and try for all the frequencies and add them up to get any function that we want. I just want to draw an analogy from that to here, so you can understand that here. So the B here will decide where the inflection happens, and A will decide what will be the slope of that particular curve. In this particular case, we got the values of sigma 6 point something and minus 4 point something if I use the Adam optimizer. So the question now is, are these weights constant or they will change, or like is there unique or they gonna change for a given problem? So why am I asking this question is because if they are not unique, so we started out saying that we want to optimize it. So by optimization we try to minimize something. So there are questions even in this. So there are something called convex and non-convex. So if you just have one solution, it means you already have attained the global minima. In that scenario, if you have a convex function, you will attain that. But when you have a non-convex function, you will not have a single minima. Instead, you will have multiple local minimas, and then you need to, it will take much more effort to actually find your global minima, which is something that we are not going into. But the question now is, is this solution unique, or we are going to can we have multiple solutions? So the hint I am saying is, if it is a non-convex, then there could be a possibility that there are other solutions as well. So what do you think for this problem? Is it going to be a single solution or multiple solutions? Like, is this the only solution, or could there be anything else? Is the question clear? Y equal to x square is a convex function, so unique solution. Y equal to x square is a convex function, that is for sure, but the point is y equal to x square is my original function, so I am trying to get that original function. So what is the function that I am trying to optimize here? This is a function I am trying to optimize now. Y equal to x square is something that I am not optimizing now. So the function that I am trying to optimize now, my objective function now is and my variables are a and b. It's not x and y, my variables are a and b, because I am trying to find the values of a and b. So this is my function now. So do you think this function is going to be an convex function? This function is what you need to comment on. Maybe in this particular case it becomes that it is a convex maybe, and then you eventually get one solution. But in general, like when you have several layers in the network, it might not actually be a convex function. In those scenarios, you cannot expect to have a unique solution. So you can have multiple solutions. So what is the problem with that? So what happens is something like, say if you have something like this, sorry. So if this is something that you encounter, so if you just have, this is my objective function, this will have so many values in between, what could happen is you might actually stop at one of these, and then the solution that you get might not be the good one. Then you might have to vary your, okay, which parameter you would vary in your optimization function? If this is your landscape, so you would change your learning rate, or you would change your gamma. Which one of these you would change if you want to move through this domain? So when you have lot of these values, you would be expecting to move a lot, so you actually have to reduce your alpha a little, so that it will take more time. So if you reduce alpha, it will take more time, but if you also change your gamma, then it will be even more difficult, because you will keep on oscillating at these points. So these are the problems you will encounter when you try to do this. But now the question is, the problem is, what happens is it will keep on oscillating. Instead of actually coming to a final value of your weights, your solution will keep on oscillating, and you might not even converge. So this is the problem this is one problem that you will encounter when you have multiple, like when you have a big network. There are other problems also which will come a little later. For now, I just want to bring the point that your solution is not going to be unique. You can have multiple solutions, and you can have non-convex objective functions. I hope the point is clear. Now we'll just take one step further from what we had in the previous one. So the previous problem was a regression problem. So the previous one was a regression problem, so this is a classification problem. So we discussed that what neural network does is essentially tries to approximate the functional form. So what are we doing in classification using a neural network is also the same thing. So if you see, the circles here corresponds to one particular kind of data, and the cross marks are for another kind of data. So essentially there are two classes. Say the circles is class 0 and the cross marks are class 1. So I want to differentiate between these two. What I am trying to do with a neural network is trying to approximate this particular circle here. So that is given by this relation x square plus y square less than or equal to r square. So if my neural network, if x and y are my axis, so what I am trying to do is I will feed x and y to my neural network as input. Then it will somehow, I am assuming that the weights inside will give me a relation, something of this form. So it will calculate some z equal to x square plus y square minus r square, or maybe I will put b square minus some constant b here. So this z, it has to somehow take the values of x and y with some parameters. It will try to come up with this function, and then what I will do is what we do usually is we will set a value of z greater than or equal to 0.5 for one class and less than or equal to 0.5 for the other class. So in that way, what will ensure is z greater than or equal to 0.5 will ensure that x square plus y square, it's like this corresponds to one scenario where x square plus y square minus r square is positive, and the other one will correspond to the negative. So this is what we are trying to do. So what neural network does is again the same thing. So it tries to approximate the functional form of this particular curve here. It is trying to approximate the functional form of this circle here. So we know previously, like for your if your function is y equal to x square, then if this is my function, then we got to know that I can use a single layer network. So if this is my x, I can use a single layer network and I can still able to map a function y equal to x square. What are the weights? Say 6.4 and minus 4.4 are the weights. With these weights, I will be able to use with sigmoid activation function, I will be able to get y equal to x square. Now what I want to do is, what I wanted to do is to map this relation x square plus y square minus r square equal to 0. So how would I design my architecture? So I will take in x as my input. I will pass it through one layer with the weight 6.4 and minus 4.4. I will pass in also y as another parameter, another input. I will use the same weights. Now I have the output of this is going to be x square, the output of this is going to be y square, and then I will use a weight factor with some bias, and then eventually I will get some z value here. So your architecture, if you design an architecture like this, then it will be able to classify this particular problem. But we do not know before that I have to use these weights and so on. So how we when we try to formulate, or when we try to give it as a problem to, say if you want to formulate it in MATLAB or something, how do you design ideally? Like you start out with something like x and y as your inputs, you put 2 neurons and 1 neuron, and then you assume that there are several of these connections with biases automatically, and then you say you have some z. For each value of xi and yi, you will actually calculate zi. From that you will get label, and then what will be your objective function in this case? So what is your objective function in this class? This is a classification problem. So what is the objective function you will be using? It has two classes. So is everything clear till here, or are there any queries? Like, did you understand everything, or are there any ambiguous things in whatever I said till now, discussed till now? So why did I come up with this? Like, is this part clear? So how did I design this particular architecture from whatever I know previously? So previously I used the function y equal to x square in order to model that. I just solve only that particular problem. Like, this original problem can now be broken into sub-problems. So the first sub-problem is solved in the previous case. We found out that with these weights I will be able to get this functional form. Now I am trying to reuse that fact. so for x and y, and then from there I'll directly get z as shown here. So this is clear, right? Are there any queries in this? The point I am trying to exploit here is your sigmoid function. If x is positive, it is going to be so depending on whether x is positive or negative, your sigmoid function will actually greater than or equal to 0.5 or less than or equal to 0.5. So when this z, depending on here what we want to identify is whether this particular x square plus y square minus r square is positive or negative. So if my neural network can actually get x square plus y square minus r square, then depending on whether it is positive or negative, your sigmoid will actually be greater than 0.5 or less than 0.5, and from there it will be able to identify whether the point given input is inside the circle or outside the circle. So here I have already used the fact that I know the weights from the previous case, which if I do not know, then I will formulate the problem in this way. Now I will be having lot of weights, and then I will have to solve them and eventually find them. So this is what the professor was referring to, sometimes called the sparse weights. So this is the original network that you have, but which you might not be requiring always. So even with these reduced weights, actually I can remove these weights, are not required. These two weights are not required. I can actually reduce them, thereby reducing my computation storage, and then actually solve the problem and eventually get to the solution. This is especially useful when you have say if you are using some CNN, okay, CNNs is not yet reduced, but when you have very big networks, when you have lot of weights, things like this will actually be useful. You actually break it down into sub problems, and then you actually assemble this and design your architecture. Okay. So is this clear, or are there any questions in this? We are halfway into the session, so if you have any queries, then maybe we will take it up. Okay, if there are none, then we will go to the next one. Yeah, in this, okay, I have yet to answer the question. So what is the objective function that you will be using for this problem? For the regression, it's a mean square error. So for a classification problem, you are going to use a binary entropy function. So what is the binary entropy function? So you will have the original value Zi. Zi is your class label times this is what your model predicts. So this is your, it's like in general you use a cross entropy. If you have multiple classes, then you will use a sigmoid of z times ln z for all of them combined. For now we will use binary entropy function because we just have two classes here, and then you solve this problem. So this is straightforward. In any of these cases, you eventually, once you have the, this is, you are going to have a sigma over all the data points. Once you have your objective function, it needs to have a minus before, just to ensure that you are trying to minimize the binary entropy, and then you need to determine your gradient. So how do you find gradient? We use backprop. So I just gave a very simple network here just to illustrate how you do backprop. So I am not taking biases here because it would just have like just for the case of clarity. So what is h1 times x, and then you have some activation function g, and similarly h2, and y is going to be So I am not going to rederive everything that is being discussed in the course. So if you can quickly come up with the answer, then we can actually skip this one, or if there are any questions in backprop, then we can take them up. So the question is, this is your y, maybe I should use y hat. Y is your original data. Say if your loss function is y minus y hat square, I just have one data sample. So this is my loss function. My objective is to update the weights, for which I would be needing the what are the values I would be needing? Gradient values. I would require the gradient of the cost function with respect to all the weights. This is what I would be requiring. So how do I calculate this? So we do this using the chain rule. So if you take the first one, we'll take the first one, say del Z del W112 can be written as y hat this is going to be, so I'm just, maybe I can ignore the 2, I'll just put a half here, so you don't have to worry about the 2. So you just apply the chain rule and then you keep going on for all the weights. So for this particular first weight, what we got is, if you forget about this term, so you have a g prime corresponding to the value stored here inside y hat. So whatever value you are going to have here is y hat times h1. So what I have done essentially is, if I replace this network, I will take the value y hat, multiply it with h1, and then I will be getting the first gradient. Similarly, I will multiply with h2 and I will be getting the second gradient with respect to W21 for the second layer. Now we will use these weights again and then calculate the value with respect to the first one. So I have my weight here W221. So say if I want to calculate this, how would you go about? Like if you are using any of these packages, then it would automatically do it for you, but for your exams you might have to do it with your hand. So how do you apply the chain rule here? So this is straightforward. So you just follow the path. So you want to reach here from here, so you just follow this particular path. So you start with y hat and then your y hat. If you see these equations, your y hat is dependent on both h1 and h2, but the value you want is W221. So W221 is only related to h2, so you have to relate only for this. So I'll write del h2. So you have reached this node. So from here you have reached the h2, and from h2 how will you relate to this? So now you have these three. So you start from y hat node, you go to h2 node, and finally reach the point that you want. So I hope there are no queries in backprop. So if you find, like Nitin already pointed out, that there are some typos or in the presentation or in the video lectures that have been shared with you. So as long as you ensure that your chain rule is properly done, then you shouldn't be facing any problem in that. So I guess there are no queries in this backprop. So we'll go to the next question. So this is for a simple problem. So if the network gets expanded, so just to illustrate you, if the network is a little bit dense, then even then the idea is similar. So if you want for a given weight, you start from the endpoint, traverse through all the nodes that are there in between, and frame your chain rule in this way, and you will be able to solve the problem, the one that is given in the assignments as well. Okay. Yeah. Now we are halfway into the session. So maybe I want one of you to answer this question. So previously you told me that there are 3 activation functions. We discussed on sigmoid, tan h, and one of you, I think Saran, okay, he pointed out another function relu as some of the activation functions that we are using. So can we use sin x as an activation function? Say for that matter cos x, like sin x, cos x, can I use these as my activation functions? So do we have any requirements for activation function? Okay, for now I'm keeping the fact that okay, it needs to be computationally least expensive to calculate that. That is something that is already taken care of. Say, let's assume that your computer is good enough that it all of the, doing any of these activation functions is already implemented efficiently. So we will exclude that fact for now. Leaving that, any other reasons do you have for choosing any particular activation function? Non-linear. So sin x is linear one or non-linear? Very hard to optimize. So okay, one of you answered it needs to be non-linear. So ReLU is actually a linear function, it's not non-linear. Okay, so very hard to optimize. So why is it, what exactly is hard to optimize? Which of these is actually hard to optimize? So maybe I'll put some names so you can say 1, 2, 3, 4 and 5. Which of these is hard to optimize? Yeah, we'll also come. First one is you need to have some non-linearity. ReLU doesn't have it. But why are we still using ReLU is because it has some truncation. Essentially, it's not completely linear. It actually, whenever the value is negative, it completely cuts it off. So because of which we were it can be used in some situations. So what we wanted is it needs to somehow differentiate it. It needs to somehow classify whatever input it comes into 2 points. So what we need is some kind of a switch that will only like a filter that will only allow some part of the information that comes in and prevents the other parts, or which to put it differently, it somehow differentiates the input data. This is what mainly required. So ReLU does that. So it actually differentiates between negative and positive. When you have a linear function, it treats everything as the same, so we don't get any much advantage from that. When you have a non-linear part, what happens is different x will have different sensitivity. That's how it is able to differentiate between different inputs, and we want that differentiation. Only because of that it will be able to predict something. So now coming to the point, ReLU is when you have positive negative, and then one of you also commented it's very hard to optimize. So what is hard to optimize of these 5? Which one of these is hard to optimize? Sine function has lows and highs. Okay, to put it maybe, yeah, it has lows and highs. Maybe I could put it something as see, you would require monotonous functions. Yeah, if you have a monotonous function, a continuously increasing or a decreasing function, it would be easy to optimize compared to periodic functions like sine, which keep on oscillating. So if it keeps on oscillating, your sometimes you will find a particular weight, and then you will really go into a different region, and then the weights have to be completely reversed. So you might not converge; it will keep on oscillating. Okay, sine functions are not good, but for some applications, it's again dependent on your application. For some applications, in some particular region, even if your x is very low, sin x can also be a kind of a linear one. You can use it for like very narrow applications, but even then, for some applications it will be useful. Otherwise, mostly you will not be using it because it is very difficult to optimize. The main requirement is you need monotonous functions, and you need somehow some kind of differentiation built into that particular activation function. If these two things are there, you will be able to use it. What are some other functions? I don't know how many of you are already familiar with Legendre polynomials. Maybe I'll write Legendre polynomial. They are another class of functions that can also be used. So they are also non-linear. They have some special properties, like depending on your problem. So these are some kind of basis functions that you will be having, which if you use, they'll actually lead to better, like with less number of neurons, you will be able to capture much of the data that you have. So it changes from problem to problem. For heat transfer applications, this is something that has been shown previously to work. But for your application, the activation function might be different. Usually, the ones that mostly are used are this. ReLU is the one that is being used nowadays mostly, but you have TANH and sigmoid. The problem with sigmoid and TANH will come a little later. Maybe I can introduce that. It's not yet introduced in the assignment, so you have something called exploding and vanishing gradients. The good point with the sigmoid is it always limits the values between 0 and 1. If you have TANH, it will always limit the values between -1 and 1. So you don't have much of the problem. So your output should always be like, whenever you have a data, you need to kind of scale it in such a way that your output will always lie between 0, 1 or -1 and 1. ReLU has no problem. ReLU will always give you positive values. So you have to scale your whatever original data you have to only positive values, then ReLU can be used. For sigmoid, these are the scenarios. But the problem is when you have the sigmoid, it will actually, like if you see the plot of sigmoid, for much of the negative values, it won't differentiate any much. So only in this particular region is where it will kind of differentiate between this. After this point, if I have a value here or here, the value of sigmoid is going to be more or less same. So it wouldn't be able to differentiate these things. So if the values are very close to 0, then what happens is when you have two different neurons, when the information is passing from one neuron to the other neuron, the value here is say 0.1, the value here is 0.1. When you multiply both of them, it will become 0.01, and then as you go on into the layer, like deep into the layers, this value becomes small and small, and it will reach the mission precision value. Like previously we discussed that computers have a finite precision, so it cannot, like when we do analytically, we can actually get 10 power minus 16, 20, 100 or whatever we want, but computers have a finite precision. So after a certain point, it will become, it will actually exceed the bits that it has, and then we will not be able to use it. So that is one problem that we have. We will come to that a little later. So that is the problem we will be having with sigmoid and TANH. That is kind of partly resolved with ReLU. That's why ReLU is being used in deep networks. And sine and cos, as he said, they oscillate, so we will not be using. Even this you will be having the same problem. If you try to increase the depth of your network, then they will kind of gradually decrease, and then that is what you call vanishing gradient. So how we resolve that is something that will be discussed in your upcoming lectures. This is a bit of more mathematically oriented one. But before going to the math, so let me ask you the question. Yeah, maybe you can go through the question. So the point here is you have certain data and you are trying to pose this as a classification problem. You are training a network, you got some data, you trained it, you got some weights, and you are able to predict everything is fine. So the problem is, what if your data that you have initially is wrong? So you can have incorrect labels in the data that you have. If it is a regression problem, the one you would be calling is you have noise. If you have a classification problem, you can say that the data you have itself is corrupted, or maybe it has some noise or incorrect labels attached to it. So what would happen in that case? How would your model, how would you change your model to handle that? So you need to incorporate that information into the model. Previously, whatever we have developed is like we just take the inputs x and y. Say if x is my input, I have my neural network. I'll predict my y hat, and then we used, say if it is a 2-class problem, what we would be doing is we will use my loss function as y times ln y hat, and 1 minus y times ln 1 minus y hat. I'll use this with a minus, and there is a summation as well if for multiple points. So if it is a single point, you will use this as your optimization function and then solve it. You will get the weights of it. Everything is fine. but this model doesn't account for the fact that your input itself is wrong. So it is assuming that for a given y, x is correct. Sorry, for a given x, y is correct. This assumption itself might be wrong. So what if you have incorrectly labeled data? How will you incorporate that information into your model? So this is the main point of this question. So what would you do in that case? So to answer that, a little bit maybe like previously we discussed for linear regression. So how did we come up with the mean square error as my objective function? I guess we discussed this already in the last week, so I'm not going over it again. So just a quick recap if to those who have joined now. So if x is what we start is we assume that x is coming from a distribution probability of x and y is coming from another distribution probability of y. What we are trying to do is, given the fact that I know a value of x, the probability of y, I want to maximize this particular quantity here. This is what we were trying to do. And then we also told that when you have a noise, when you have several sources from which your noise is coming, based on central limit theorem, you can approximate it with a Gaussian distribution. So this becomes a Gaussian distribution when you have multiple sources of error. So with some mean mu and sigma, some variance. So what we try to say is, when we try to model using a neural network, or for that matter linear regression is what we discussed in the last session. In linear regression, we try to approximate this mu with your y hat. And if you try to when you write the distribution for this, you have an exponential of minus y hat square by 2 sigma square, and then you have some coefficient here that will make the PDF to be 1 when integration of PDF to be some normalization factor. But if you want to maximize this particular quantity, you need to minimize this one here. So that's how we came up to the conclusion that you want to minimize y minus y hat square. This is for the case of regression. So now if we apply the same logic here in case of a classification problem, now what we have is in classification problem, what is your probability for y is, previously it was a continuous distribution, so you were able to do it using Gaussian was able to do it, but now it is a discrete distribution, discrete random variable. Y is a discrete random variable, so I cannot use Gaussian directly, so I need to come up with another form for it. So what is it that I want now? I want to maximize the probability of y given x. So what is the value of y that I would be wanting? Or y hat is my model. So what is the value of y hat I want? Y hat should be 1 if y equal to 1, and it should be 0 if y equal to 0. This is what I wanted. So how will I write this mathematically? Or maybe let me simplify this even better. So let's say if I put it in this way. So in the problem the notation is slightly different. So I am saying t as my output, y as my output, and t is the class label that I am using, and I am saying my output of the model is probability of t equal to 1. So what I am predicting is the probability that the given label is of class 1 is what I am trying to predict. So probability of t equal to 1 given x is what I am trying to predict. So if t equal to 1, this will be say y hat, or maybe I will say y is your actual one. If t equal to 0, this is going to be 1 minus y. Is this part clear? So if t equal to 1, I want the value to be exactly equal. If t equal to 0, I just want it to be reversed, so I will use 1 minus y. Is this clear? It's like I told that the output is y instead of y hat, so I am using that same notation here. So yes. So I want to write, like, this is a piecewise function. I want to write it with a single function. So how will I write it as a single function? So the one that is one way to do about this is if I write this as something like this. So when t equals to 1, this particular quantity will go off, you will be left with y. So if I write this as this, if t equal to 1, this comes out to be y. If t equal to 0, this comes out to be 1 minus y. So this is exactly equal to this function here. So if this is exactly equal to this, so what I am trying to do is approximate this with this function. And what I will do next is I want to maximize this, or to maximize this, I would maximizing this is equivalent to maximizing the ln of this function. Since it is say if I take a ln of this, it's going to be t ln y plus 1 minus t ln 1 minus y. So maximizing this is equal to maximizing this. So I would try to maximize this function. So my cost function is actually when you try to minimize something. So I'll put whenever I want to put as a minimization problem, I'll just put minus before it. So maximizing the original function is same as minimizing the negative of that function. So this will be my objective function. This is your binary entropy function. So this is a scenario when you don't have any incorrectly labeled data in your training data set. Now what the question says is, now that there is a probability epsilon that the class label on the training data point has been incorrectly set. So now there is a probability epsilon that you already know that there are say 10% of your data set is wrong. So now you have two options. One, reduce that 10% of the data directly if you know that they are wrong. But the point is we don't know exactly which data is wrong. So we are trying to model that as well. So you know that there is something wrong in your data, but you don't know what exactly is the mistake in your training data. So how do you incorporate that information into your model? So what we are saying is, if you recollect the truth table we have, so we have 4 different possibilities. So we have true, 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 false. So if you recollect this table, so what we are saying now is, even if the actual one is true, but there is a slight probability that this is the ground truth, and this is your labeled data. So if something is actually true, the probability that your labeled data is also true is what I am saying, what is given in the question as, or maybe I'll write this first. The ground truth is true, but then it is incorrectly labeled with the probability epsilon. So this particular thing is epsilon. Similarly, the other case is epsilon, and the remaining ones are 1 minus epsilon and 1 minus epsilon. So these are the probabilities that are given to you. Maybe based on your prior experience, you somehow came up with this estimate that there is this percentage chance that your labels are incorrect. So now with this, what we will do is, how do we change our original model? Now I have a y hat, I have my model, I got the value of y, like when for a given x, for given w, I will get the value of y. And then what I would do is, this y can be true or false. So previously what I have done is, I have just taken the probability that t equal to 1 given x as y power t times 1 minus y power 1 minus t. But now I know that y is not exactly y. It will be the true value with the probability 1 minus epsilon. So I'll just take the expected value of y, which is 1 minus epsilon is the true value, and it could be false with the probability epsilon, in which case I should be actually inverting the value. So if my model predicts it as s, I should change it to no. So I'll just write 1 minus y whole power t times 1 minus the same thing here. Is this part clear? So what I am doing, maybe I will write this in a simpler way. So I am just writing it as y hat power t 1 minus y hat power 1 minus t, where y hat is given by, previously I am using the whatever my model is predicting, I am using the same one. So instead of that, what I am doing now is I am using an expected value. If y is what my model is predicting, I will use the same value, like I am just taking it a weight value, weight average of that versus the other one, and then I will use it in my objective function, and then I will try to find my parameters that will actually minimize this new objective function instead of the original function. This way my model also knows the fact that there is a probability epsilon with which the data itself can be wrong. So it will take care of that during the optimization. So is this clear, or are there any queries? What does epsilon signify? So what epsilon tells here is based on whatever prior experience you have from the particular data source, you know that there is a probability epsilon that the data source itself can be wrong. So say if you have maybe one example that we can take. So if we see in this particular problem, this is a clear circle, like the circles and the crosses that I have given. So what epsilon tells you is that there is a probability that a circle, these are like your anomalies or the outliers is what you usually call. So there could be circles outside, but then those circles are not actually the true data. They happened because of some error in the collection of data process itself. So your model should not account for these circles inside it when it is actually training. Okay. Yeah, the question now maybe you might be asking is, how do I know the value of epsilon? It's like if I want to use this objective function, I need to know the value of epsilon, which I do not know before. So it depends on your prior experience, as I said. So depending on your prior experience, you would know how reliable the particular source is, and then you would choose the value of epsilon in this. So with this objective function, your model will be more robust. Now if you substitute epsilon equal to 0, you will eventually get back your binary entropy function, which otherwise is this particular function. So I hope this is clear. Are there any other queries in this before we move on to the next question? Yeah, the last part asks how can you extend this method for a multi-class problem. So it's going to be straightforward. So instead of 1, you will be having, like here you have t ln y, 1 minus, instead of 1 minus t, you will be having that particular label times ln of that particular one, and then it just keeps on summation of all those quantities. So instead of y, you will be taking that particular probability into account. So I hope the question is clear. Okay. There are no questions. Now let's come to the next question. So whenever we are doing these problems, what we are saying is we are trying to minimize an objective function. We are not exactly making it equal to 0. We are just trying to minimize it. So say if y is my original function, y of x is my original function, and g of x comma w is what my model is predicting. What we are doing is we are just minimizing this one. So that doesn't mean that y will actually be equal to g. So this is clear, I think by now. You might this should have been clear to you that we are trying to only minimize it, but then it won't actually be 0. So in that scenario, will y satisfy the constraints? Will the model g satisfy the constraints that are satisfied by y? Say so there was a question even on pins before. So when you are using pins, you are trying to solve a physical problem of your choice. So that has to satisfy several other constraints, but then you are approximating it with another function. So you have original function, but then you are approximating it with a neural network. So if my original function is satisfying some constraints, so this neural network, will this also satisfy the same constraints? So is the question clear? So all I am saying is, say if your original problem also satisfies these constraints, say ay plus b equal to 0, will ag plus b equal to 0, greater than 0, less than 0, or you cannot say anything about it? Can I comment anything on this particular thing? If ay plus b equal to 0, can I comment anything? Ideally it should. So why it should follow this? So this is not, then y is not equal to g for sure. So yeah, so one answer is this, so it will be equal to 0. So if y is not equal to 0, you are just trying to minimize this, and then so how did you come up to the conclusion that it should actually satisfy this constraint? Okay, maybe I should ask you, maybe I can ask something like this. So say if y satisfies this, and then what about this? Ideally it should, 0 error. No, I'm saying error is not 0. Like you are training the model, but then your error is not 0. You cannot assume that y will be equal to g, right? Which can or cannot happen depending on the type of model you have chosen. If your model is biased, like if your model has high bias, then this particular quantity is going to be some definite positive, like it will be some positive value. It's not going to be 0 if your model is biased. And even though your model is correct, it can so happen that your input data, like the one that we discussed previously, your input data could have noise in itself. Because of the noise, this value will be some finite positive value. It will never be 0 always. So y will never be equal to g exactly, except for some synthetic data that you might have generated. But ideally in most of the real cases, y will not be exactly matching g. Okay, now what about the second case? So if this is satisfied, will this also be satisfied? Ag square plus bg plus c. So would you stick to the same thing, or would you change anything? So why is this particular point that I am stressing here is, when you are trying to solve your problem, sometimes you might have to give some constraints in your optimization in addition to your mean square error. So mean square error is what you are trying to optimize, you are trying to minimize. In addition to that, sometimes you need to specify constraints. But if you know that there are if you already know that if the original function satisfies this, the whatever function you obtain by minimizing the mean square is also going to satisfy this, then you don't have to put that optimization you don't have to put this constraint into the optimization. If you know that it is not going to do, then you have to put it as another term inside your optimization function. So knowing this fact will actually change your optimization function. So you need to know beforehand whether it will actually satisfy or not. That's exactly why I just put this question. So the context is clear. Now keeping this with this context, maybe now you can tell me whether the second one is which of these three will happen in the second one, or maybe let's stick to the linear case first. So when you have this linear constraint, so you mentioned that it should satisfy when there is a 0 error. So if the error is not 0, will it satisfy even then or no? Like a simple one, yes or no? Yes. So why do you think it will satisfy? So the answer is even without even if the error is non-zero. So even if y is greater than z, Mr. Ravi Shekhar, okay, he tells that if ay plus b equal to 0, ac plus b will always be 0. So how did he come up to that conclusion? So if we were to see, like one way to actually put it mathematically is, when you are trying to minimize y minus c whole square, what you are trying to do is making the derivative equal to 0, like the gradient equal to 0. In this way you are ensuring that y will be as close to g as possible. So if y is as close to as g as possible, then a times g plus b can be written as we already know that this particular quantity is 0 because y is satisfying the constraint. So a times g minus y is what you have. So this thing can be close to 0. It won't be 0, but then it will be close to 0. So if your mean square, if you try to minimize the mean square, then you would actually have a 1 with this second scenario. But how about the second one? So if it is quadratic, will it satisfy the second one as well? If we just do the same process for the second case, so you have ag square plus bg plus c. So if I write it in the same way, I just group the terms together. So you have a times this error plus you have ay square plus by plus c, and you also have one more term. So this term is 0 because the original equation satisfies this, and this particular term will be close to 0 if your g minus y is, this actually happens for any of the function that you choose. So the point here is, as long as you try to do minimize mean square error, then this particular quantity will be close to 0, so that this entire term will be close to 0. So you don't have to additionally put this constraint into your optimization function. So by doing your mean square optimization should be enough to actually take into account of all these other constraints that you have. Yeah. Any questions in this? Okay. If there are no questions, then these are the questions I have for today. If you have any other questions, then we can discuss them. Yeah, if there are no questions, when input is corrupted, say maybe we'll take 3 labels, so y can take on 3 values. So what can happen now is, say we have 3 different possibilities, say epsilon 1, epsilon 2, epsilon 3, where epsilon 1 is the probability that the ground truth is true but label is false. Similarly for epsilon 2 and epsilon 3. So what we want to do, we construct the model normally. So you take in x, you predict yi. So this is normal as you do, but now what we do instead is this yi will come up with a new variable yi hat that will change the y depending on your actual value. So your yi hat can actually be the same as yi, or in this case it could actually be changed to, previously we just have 0 and 1, so maybe I should use the 1 hot vector, then it will be a little easier. So if I use 1 hot encoding, so depending on this, say if I call this y1, y2, or maybe I should use different variable. So maybe I'll call this z1, z2 and z3. So pi hat will be equal to y z1, z2 or z3 with different probabilities, 1 minus epsilon 1, 1 minus epsilon 2 and 1 minus epsilon 3, where epsilon is your probability for your that your data is wrong. So now this y hat, now you have to accommodate this. I'll just take the expected value of that. So if it is false, then you actually change the value of it into 1 minus z1. So what happens if you do that is you actually reduce this to 0. Previously because it was close to 1, so you change that particular value to close to 0 only for that particular label, and then otherwise you will use the same value as before. Similarly for the other two cases, so you have epsilon 2 So now what happens is, if your z1 previously this particular quantity is 1, now with a probability of epsilon 1, it will actually remain change to 0, and otherwise it will actually change to 1. So this will be your new function that you have to use instead of y hat. So previously your objective function was sigma yi ln yi hat. Now in place of yi will be your actual one, so in place of this y hat you have previously, now you will write as this particular quantity. So maybe I'll put epsilon I. Is this clear? Any other questions? If there are no questions, then maybe you can, maybe we can drop the session for today. Thank you. If there are no questions, then maybe I'll wait for a couple of minutes so you can actually go through the week's lectures, and if you have any questions, then we can discuss. We have 15 minutes for the session. So I guess there are no questions. Okay, then we'll end the session for today. Thank you for joining. If you have any feedback that you want to give, you can give me now, or like you can type in the chat box, or if you want to, like a Google form is also shared with you to share your feedback on the problem solving sessions. So if you want any specific type of questions that you want me to discuss, yes. You have something to ask? So you have something, yeah, you can type in the chat box. And as I was saying, you can also fill the feedback form. So I'll go through that and then we'll try to incorporate in the upcoming sessions that we have. If you find the questions difficult or easy or different. The last question example of a cross entropy. I did not understand assignment for last question regarding graph problem. Is the deadline for assignment 4 completed, right? So the graph problem is essentially your training and validation. So basically you have a training and a validation one. So how do you understand whether your model is correct or not? So training is what your model, so you have something like this. If I recollect correctly, you'll have something like this, and then something like this, if I recollect exactly, or maybe just give me a second, I'll open the question. If you already have the question, maybe you can share your screen. Yeah, so the important point here that you need to understand to solve this question is what is the difference between the training and validation loss, and how is it changing with respect to your number of iterations. So if you recollect the bias and variance, so what you mean by bias is a model is not able to understand everything within the data itself. So if the model sees only your training data and not your validation, if the difference is large, like in the first case, this is when you say that your model is very biased, which means it was not able to capture the entire relations just from your training data. So if you happen to see like something in the last one where both the training as well as your validation are close to each other, it's like they're kind of very close to each other, which means your model has been able to capture it properly, like it is able to understand the training data properly. So maybe you can tell me what exactly is the challenge that you are facing. So what exactly is it that you are facing difficulty in this? The question asks you to understand which of these has a poor generalization on validation data. What they mean by generalization is that model is able to capture the relation properly or not. In order to understand that, what you have to see here is what is the gap between your training loss and validation loss. If the gap is too large, then the model is biased. So in the three graphs that is shown here, the first one has the gap is more, so it will be the more biased one. Yes. Maybe you can ask another question on this. So out of these, maybe you can answer that. Out of these three, which one do you think has more variance in it? So there are two things. One is bias, the other one is variance. Variance is with respect to that particular model. So which of these three models do you think has more variance? first one has more bias. Yeah, okay, I was actually referring to her, so she could actually answer it. Graph 3. So you are clear why does it have more variance? Here both the training and validation laws are close to each other, but the error is actually quite higher compared to the other two cases, so you have more variance in that. Yes. Yeah, I think that answers your question. If there are no other questions, then maybe we can end the session for today. If you have anything, yeah. If you do not have any other questions, feel free to leave the call. Maybe I'll wait for another 5 minutes and then we'll end the session for today. Yeah, I think there are no questions. Okay, thanks for joining. We'll end the session for today.